We are talking about transformations of quadratic functions. And you want to describe transformations of quadratic functions and write transformations of quadratic functions. So the first one that we're going to start with is f of x equals x squared is the parent function. And so we have x, y, and we'll set those up in a coordinate table. And we'll just substitute in 0, 1, 2, and 3. So when we substitute those in, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So when we go to graph these, we have 0, 0, 1, 1, over 2 up 4, and over 3 up 9. So we have the parent function that graphed looks like this. Next one we have is g of x, and we'll make that one blue, and we'll do the same thing. So we have our parent function, and then we have our coordinates that we'll substitute in. So we'll pick the same point, 0, 1, 2, and 3. So 0 squared, and then times 2. 0 squared is 0 times 2, that's still 0. And then 1 squared times 2, 1 squared is 1 times 2 is 2. 2 squared times 2, 2 squared is 4 times 2 is 8. And 3 squared is 9 times 2 is 18. So if we look, our x value stays the same, but our y value doubles. So 0, 0 is still there. Then we go over 1. Instead of going up 1 with the parent function, we go twice as high. So over 1, up 2. And if we go over 2, instead of going up 4, we go twice as high. So we go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 318 is off of our graph, so we can't graph it. But we can see that that 2 out front scales the parabola so that it grows twice as fast in the vertical direction. And then we can look at what it means for 1/2. So we can set up our grid, our table again, and we'll pick the same 4 points, 0, 1, 2, and 3, and we'll do the same thing. So 0 squared times 1/2 is still 0. 1 squared times 1/2, let's put that in parentheses. 1 squared is 1 times 1/2 is 1/2. 2 squared times 1/2. 2 squared is 4 times 1/2 is 2. And 3 squared times 1/2. 3 squared is 9 times 1/2 is 4.5. So when we compare this to our parent function, we see that the x values are still the same, 0, 1, 2, 3, 0, 1, 2, 3. But our y values are cut in half. So 1 goes to 1/2, 4 goes to 2. And so this one gets, so over 1, up 1/2. Over 2, up 2. And over 3, up 4.5. And so we can see that our graph is a little bit wider than the parent function.